Welcome to my projectbazaar.com. Now let us discuss about the local configuration pattern features for age-related macular degeneration, characterization and classification. Now let us discuss about the abstract of the process. So here in this proposed work, the input image is taken as a fundus image in the dataset. So fundus image is collected in the dataset. So that is one image is being collected in the fundus image, and the dataset are implemented as an input image. So in the input images are taken from the format of .jpg or .png format, and then the process. So in this pre-processing stage, the collected fundus image are subjected to the pre-processing. So in the pre-processing step, here we are reducing the noise by using the Gaussian filter, and also in the pre-processing step we can implement the histogram equalization and also the channel separation. So in the channel separation process, here we separate the channel from red, green, blue, channel perform or outperform, and then next step is a feature extraction. So in the feature extraction process, we can implement the LBP. So by using the LBP to extract the feature from the pre-processed image. So LBP is called also known as a local binary pattern. So LBP is widely in the LBP local binary pattern, LBP is widely used to extract the features from the medical images. In the feature selection process, here we implement the genetic algorithm that is called as a GA. So by using the genetic algorithm, we selected the particular feature of the process. So finally, in the classification process, we can implement the SVM. So that is a support vector machine. So in the machine language, the machine level language to support all supervised learning models with associated learning algorithm. So the analysis of data used for the classification and regression analysis of the process. Finally, performance analysis can be done to find the precision, recall and then accuracy of the process. So the overall simulation process is done by using the MATLAB. Now let us discuss about the flow diagram of the process. So these are the overall flow diagram. In the first of all, it has a 6 modules. So in the first of all, the first input image. So here we selecting the fundus image. So the data set will be selected. One image it will be getting the input image, and then in the pre-processing. So in the pre-processing step, here we using the histogram equalization and RGB channel separation. So in the histogram equalization process, to equalize the histogram technique by using the graph of the process. And then channel separation, here we using separate the channel red, green, blue. So to separate the 3 channels in the pre-processing step of. And then the feature extraction. In the feature extraction process, we using the LBP, that is a local binary pattern, to extract the feature from the pre-processing image. So by using the LBP algorithm to extract the feature from the pre-processed image of the process. So the local binary pattern to optimize the local values, that is a fundus image by selecting the feature value to estimate whatever it may be the fundus image should be have a disease or not, or any other classification is done by using the LBP process. So in the feature extraction is done by using the LBP. And then the feature selection. In the feature extraction process, all the features it should be extract from the pre-processed image. In the feature selection process, to select a particular feature in the feature extraction process. So here we using the genetic algorithm. So genetic algorithm is an inbuilt function in the MATLAB process. So by using the genetic algorithm, we can calculate the feature selection to estimate whatever it may be. It may be the best feature value which should be calculated by using the feature extraction process of the particular feature selection. So in the value will be calculated whatever it may be, it should be wrong or not. So this is a fundus image or not. So like that. So by calculating the genetic algorithm, the process it should be calculated the feature selection to estimate the previous step of the feature extraction process. Finally, in the classification process. So in the classification process, here we using the SVM classifier. So SVM classifier is a type of a best classifier for the support vector machine. So by using the SVM classifier, we should classify the fundus image, it should be medical image or not, or rather than whatever it should be calculated. So that is in the classification process. To classify the fundus image, it should be the particular value should be disease or not. So whatever it may be, SVM classifier it should be efficient and also easily calculated. So SVM classifier is also an inbuilt function in the MATLAB process. So easily to analyze the classification process, and the accuracy and precision recall value also finally estimated by using this process. So these are the overall flow diagram. And also important main models are input, pre-processing, feature extraction, feature selection and also classification. So these are the important models, and then these are the overall flow diagram of the particular process. Now let us discuss about the running procedure for the process. To click the main file, and then run. So it has some time to select the dataset from the dataset of a fundus image. So I will click that. It's going on the processing. So yeah, let's check. Yeah, sure. So in this process I will click the dataset. So these are all the fundus image of the particular process. So whatever it may be, I will select it. So I will select the first image. So all the process, the format of TIFF format. So I will click open. So all the process, I already told that there are 6 models. First of all, get the input image, and then second one, the pre-processing. So in the pre-processing step, here we are using the histogram equalization and then RGB separation. And the next process is feature extraction. By feature extraction, here we are using the LBP, and then feature selection. And then feature selection process, here we are using the genetic algorithm, and finally the classification process, here we are using the SVM classifier. So these are the 6 models in the particular process. So I will discuss about one by one. Yeah, this is the first image. So I will select the first image, that is called a TIFF image. So this is the input image of the process. So in this next figure, yeah, this is second image, third image, fourth image. So these are the channel separation of RGB. So red channel, green channel and blue channel. So these are the 3 channel separation from the pre-processing step of the process. Yeah, in this image it should be like a histogram equalization technique. It should be applied. By using the histogram equalization technique, the fundus image should be the image it should be affected or not. So this is the figure of the particular process. So in this next figure, that is also like a, because we separate the images RGB, so it will be applied 3 types of process, and then RG and then the B. So these are the 3 types of process particular in the LBP feature extraction. To extract the feature by using the red channel, green channel and then blue channel. So all the channels should be applying the feature extraction process. And then the next figure, so these are the 3 figures. Yeah, and then the next figure, so this is the values to extract the features. So these are the values particular fundus image to extract the feature by using the local binary pattern of the process. So in the next figure, so this is also a feature selection. By using the feature selection process, particular 256 resize, so that will only be selected by using the genetic algorithm. So this is the optimization toolbox of the particular MATLAB. So this is the genetic optimization toolbox. This is also an input function of the process. So feature selection by using this process. And then training features. So training features means I have 20 images in the data set, so I will extract the features for 20. So that's only displayed 20 cross 20. So I will select it. So these are all the image for a particular process. And the next figure, selected the text feature. So first of all, I will select the first image. So I will select the first value. So this value it should be displayed in the selected text feature. The both are same. Yeah, this is the selected train feature. So these are the difference between the selected train feature and the selected search feature of the process. Finally, the classification. So in the classification process, here we are applying the SVM classification. By using the SVM classification, the fundus image it should not be affected. So finally, it should be shown in the message box. The fundus image is not affected. So these are the overall running procedure for the particular process. Thank you for listening this video.